Okay, so today's lesson is chapter 3, lesson 9. Title of this lesson is Placing the First Digit. Boys in the corner. Someone's going to have to move if you can't be quiet. Ready? Let's try that again. So, placing the first digit. Let's talk about what that means for today's lesson. So, we've been doing long division. This is still part of our long division chapter. Today, we're talking about what do you do if you're dividing in and the number on the outside does not fit into the number that's under the bar. We've done a couple of problems like this before. It just happened to kind of pop up in a couple of the lessons that we've already done. So remember how we held the place with an X or with a 0, and then we divided into the first two digits of the number. So that's what we're going to work on today, is where you're going to put your first digit. We talked about how it was really important to make sure that when you're placing your digits that they're directly above the number that you're looking at, because you want to make sure that you don't skip any numbers. So if your dividend has 3 digits, your answer should have 3 digits above it. If your dividend has 4 digits, your quotient should have 4 digits also. Okay, so that's what we're going to be talking about today. Even if it's a 0 or a placeholder, you need to make sure each of the numbers that are in the dividend. Correct. Right. But you just need to make sure that they're all lined up. Okay, so here's our essential question, the strategies that can be used to divide whole numbers. Just like what it's been for all the other 8 lessons of this chapter. So each day we're learning a different strategy that can be used to divide whole numbers. Basically, the strategy we're going to talk about today is when you have bigger numbers that you're dividing under the bar and they do not necessarily go in evenly. Okay, that's what we're talking about. So here's your problem of the day. Which number is less? 1,000 more than a million or 1,100,000? So they've written these two numbers in word form, short word form really. And so you're going to then tell me which one is less. So try to write both of those numbers in standard form, and then you're going to compare them. What would be 1,000 more than a million, Malachias? What did you say? 1,001,000.
Yeah, it's actually true.
So that's the first number. That's this one right here. 1,000 more than a million. It's like a million plus 1,000, right? And then what's the other one? 1,100,000. How would you write that one, Sean?
You would write it 1 apostrophe.
You mean comma?
Comma.
Okay.
1 comma.
You got it.
Comma 1 0 0.
There you go. Comma.
Comma 0 0 0.
Got it. So which one is less? Karnpreet, which one is less? 1,001,000. So this number is less. Because if I were comparing my digits, the 0 in the 100,000s place makes it less. Okay? You can erase your board. Then you can look at your math notes. So make sure that you have the title of today's lesson, place, that's a C, the first digit in your notes. The question says, what would happen if you place the first digit of a quotient in the incorrect place? So I'm going to give you an example of that. Watch my example. I'm going to make sure I get the right question. No. I'm gonna make a different question. No. Okay, watch. So the question asks, what would happen if you place the first digit of a quotient in the incorrect place? So if I were dividing 4 into 238, and I try to divide 4 into 2, and I say, oh, that doesn't fit. So I'm going to divide 4 into 23, right? That was what we talked about. And then how many times would 4 fit into 23? We've done questions like this before, but Nolan, how many times?
5, because it can't go quite 6 times, because that's 24.
Right.
Almost 4, sorry. But
So-
it can only go in 5, and minus 20 and all that.
So now I'm going to multiply 5 times 4 and I get 20. Then I'm going to subtract. Then I'm going to bring down. And now I'm going to divide 4 into 38. So how many times does 4 fit into 38? Karnpreet?
9 times.
9 times. 9 times 4 is 36. When I subtract, I get 2. So, but look what happened. Is I didn't place my first digit in the right spot. When I'm looking, remember how I showed you this on the lesson the other day? If you, each of these numbers that are in the dividend should also have a number above it in the quotient. So the numbers underneath the bar, since there's 3 digits, a 2, a 3, and an 8, then my quotient, which is my answer, should also have 3 digits. So here's how you may think that, oh, that doesn't really make that big of a difference, but it will, because we're going to be doing some dividing with some numbers that sometimes don't fit, and that happened before too, where you need to put a 0 in the top. Nod your head if you remember where we had to put a 0 as a part of our quotient. So it's really important that sometimes the 0, you forget to put the 0 up there, and then when you go back and you look here, you might remember, like, oh, I forgot to put a 0 and I should have. So you could put it, yes. So he's asking, could you put an X? So like this, if I'm going to redo the problem, when I'm dividing 4 into 2, it doesn't fit. So the things that you can do here are, you could put a little dash to like hold the place. You could put an X here to hold the place above the 2. Or if you want to stick to numbers, you can put a 0 there to hold the place. None of the placeholder will not show up in your actual answer. So when you go to choose an answer on your math test, or when you go to type an answer in, I'm not going to write 059 as my answer. I'm just going to write 59. Okay? You don't need to keep the placeholder is just there to hold the place. So that 0 is right above the 2. So because it didn't go in evenly, remember we're looking at the hundreds. So because 4 does not go in evenly to 200, now I need to break the hundreds up. I want you to think about what we're doing. I want you to visualize when we're drawing pictures. Okay? So think about it when we draw the pictures. If you have 200 blocks, think of what 200 blocks looks like. And I have 4 circles that I'm trying to divide it up amongst. If I only have 200 blocks, but I have 4 circles, don't I have to break the hundreds up into tens? Remember when we did that and we broke the hundreds into tens and then we could move them around? So that's why now we're doing 4 divided into 23. So just like we did over here, 4 goes into 23 5 times. 5 times 4 is 20. Bring down the 8. 4 still goes into 38 9 times. And that equals 36 with the remainder of 2. So our answer really didn't change. But what this lesson is reminding you is that you need to make sure that the first digit is placed in the right spot. So raise your hand if you would rather use an X there as a placeholder. Raise your hand if you use a 0 as a placeholder. What about a dash? Just a little dashed line. Okay, so any of those will work, and it all is the same thing. As long as you're holding the place so that once you put your number up there as your answer, you're able to make sure that each of the numbers in the quotient have a number that's right above part of the dividend. Let me show you what that picture would look like, because I was telling you about the picture. I'm going to erase this one. That was the incorrect way. Watch the picture. This is why we drew the pictures, because that way you can think about it in your head of exactly what we're doing. If I have 200, they look like this. 30 would be 3 of those, and 8 ones. If I have 4 circles that I'm dividing those amongst, Can I divide those 200 blocks among 4 circles?
Sort of.
Sort of how?
Sort of, because you could split them. And you know how on the virtual manipulatives, you can put them together but not quite into 100?
Yeah.
You can put them into 50 blocks.
Well, let's not put them into 50 blocks. We're just going to use either
But
tens,
yeah,
hundreds,
and-
or ones.
Well, yeah, you could split them up, but it could sort of go into it.
So
like
it can go in, but not in the form that it's there. Is that
200,
what you mean?
But not 200 blocks.
Right.
200, not 200s.
So instead, so it can go in, just not in the form that it is as 200 blocks. So that's why we're now using the 23. We're saying it's 23 tens. And that's what I have. 5, 10, 15, 20, and then the 3 ones that were left over. So I need you to make sure that you're relating what we've done on the drawing the pictures to what we're doing here. You don't have to draw a picture today, but I want you to be thinking about it. That's why we're doing that. So that's why we don't put our answer in the hundreds place, because we didn't distribute the hundreds. We are distributing tens. So because we're distributing, you broke up the hundreds and you made them tens, and now we're distributing those amongst the circles. And that's why our answer goes into the tens place, not into the hundreds place. Okay, here's another example. I want you to write this one in your notes. 286 divided by 3. So when I rewrite it, the 3 goes on the outside of the bar, and the 286 goes underneath. You write this in your notes. Now, if I'm trying to divide 3 into 200, right, that's what I'm doing, is 3 into 200. Doesn't work. If I have 3 circles, I can't divide 2 amongst the 3 circles. I need to break it up into tens. So I'm going to use a 0. You can use an X, you could use a dash, whatever works best for you. Taking notes.
Oh, I thought
You thought we were drawing pictures on the whiteboard? I'm taking notes. Hold on. Let me finish this one. Lunch helpers, welcome back. Have a seat. Quickly. So we can keep going. You know what we're doing. Just grab what you need. Now, I'm dividing 3 into 28. So how many times will 3 fit into 28? How many times, Seema? 9 times. That's our divide. Then we multiply 9 times 3 and we get 27. I was saying 3 in writing. Okay. Then we subtract and we get 1. And then we bring down the 6. How many times does 3 fit into 16? Hamza? 4. No. More than 4. 5. 5 times 3 is 15. And then you get 1. If we would have put 4, we would have had 12 there. And then when we subtracted, we would get our remainder is more than the number on the outside, so we know we did something wrong, right? So then my answer is just 95, remainder 1. Remember how I said the 0 in the front or the X or the dash, you don't need to put there. That's just a placeholder. Aiden.
Every problem on math will it have like all will it always have to
Will it always be like that? I think mostly. I'll wait for your conversations to come to a close. Was anybody in the back able to hear Aiden's question? That's because I called on him and then people started talking. Remember, when someone is speaking, you need to look at them and you're listening to them, because that shows that you're paying attention and that you're being a good listener. You may have the same question that he has and you can't hear it, then you don't get to hear the answer. So he asked if all the questions in the lesson were going to be like that. Most of them are, not all of them. There might be a couple that don't work like that, but for the most part they will work that way. You do not put the 0 as part of your answer. You leave that part off. Here's another example, one last one for your notes. Try that one by yourself. Okay, so if I'm writing it like this, I'm going to ask you for some steps. So what do I do first? Malachias, what would I do first?
You would put an X or a 0 there. Because 7 can't go into 5.
Perfect. So because 7 can't go into 5, I'm going to put an X or a dash, or I'm going to put a 0. I like to try to stick with numbers at least. But if you want to use an X, you can use an X too. So what do I do next? Since it can't go into 5, does that mean I'm finished with my problem?
It's 7 divided by 55.
55. So now I'm going to use 55 instead. So 7 goes into 55. Sean, how many times?
It would go into it 7 times.
7 times. And 7 times 7 is 49. Then when I subtract, I get 6. Bring down the 2. What's next, Nolan?
Okay, 7 goes into 62 8 times because 7 times 8 is 56. So then you subtract that. And I don't think it's very common that you get a remainder this size. I mean, it's not very common.
As long as it's smaller than that number, it's okay.
Plus, I had a question.
Okay.
What if you're dividing like a 4-digit number by a 2-digit? What would you do?
We have not gotten to that yet, but we
Is
will.
there something special?
No,
The negative.
it's just a bigger. Do you mean the number on the outside has 2 digits and the number on the inside underneath the bar has 4?
No, Aiden, I'm not talking.
Okay, that would be that would be something you'd have to actually it would come out as a decimal because you would add a decimal to the end and then you'd start doing some
Still,
things.
what I'm trying to ask is.
If you have a 2-digit number on the outside of the bar, it's just bigger numbers that you're working with. So you're going to divide. It definitely
Twice.
no. You divide like if you had like 25 on the outside of the bar,
15 into.
right?
So you would have
You're just dividing it with a 2-digit number. So instead of a 7, it would be a 14
So you're
or
gonna
a
have to
20.
do that strategy more often.
Correct, right. Because it definitely wouldn't go into the first number. Right. I see what you mean. Yes. Okay.
Okay, so you're
Malachias, did you have a question?
This is why they're using this.
Yes, that's why. Yes. It is. Estimation is a great way to check your answer. Here's what he means by that, I think. It's really easy to accidentally forget a 0, or it's easy to accidentally have your numbers in the wrong place. So instead of getting like 170, maybe you just get 17 by accident. So if you did an estimate, that would help you to make sure that your answer is reasonable. That's what an estimate's going to be for. Okay, look at your math page.
okay.
It says that Raven received 135 emails over 3 weeks. If she received the same number of emails each week, how many did she receive in the first week? So, just like Malachias said, a good way to start this one out is to use an estimate. So they're estimating the 135, they're rounding it up to 150 because 3 goes into 15. Remember, we're using some compatible numbers, so we can do that rounding in our head and estimating in our head. So 3 goes into 15 5 times, and then we'd add the 0 to the end. So our estimate's going to be somewhere around 50 is what our answer should be, right? So first step number 1 is dividing the hundreds. 3 goes into 1. If there's not enough hundreds, we're going to regroup. Remember, that's why I showed you the picture a few minutes ago, because I wanted you to visually be able to see what it is that we're doing. So because 3 can't go into 1, what they started to do was they just moved the number box to the next one. I'm going to go ahead and put my placeholder here so that I don't forget. Now I'm going to divide the tens. So it's 3 divided into 13. So 3 can go into 13 4 times. 4 times 3 is 12. Then I'll subtract and get 1. Bring down the 5. So now I'm dividing 3 into 15. 3 goes into 15 5 times. 5 times 3 is 15. With a remainder of 0. So my answer was 45. My estimate was 50. So if I'm checking for reasonableness, I'm trying to see if it's a reasonable answer. And 45 and 50 are pretty close, and so I think that my answer is probably correct.
If you get them in the same 10,
Yes. Any questions on example number 1? Because we've done division before. So this lesson is kind of similar to a lot of the lessons we've already done, except most of these questions are not going to go into the hundreds place. They're not going to go into the first digit. That's why. That's the only reason that makes it different. Nolan.
What if someone accidentally, I'm just saying, not like not like I've done this before, but what if someone, when they did 3 to 1, they accidentally multiplied and got 3? What if that happened?
Oh, there's lots of really strange things that happen during long division. Lots of strange things. So it could happen. So just make sure you look really closely and double check all your answers.
And I was going to ask, what if someone used a totally different estimate and their estimate was way off, but their answer was right? What would happen?
Well, the estimate, hopefully you get how to do the estimates because they're supposed to help you not make it harder. So if you're not understanding estimates, you should come and see me so that I can help you with it. But just in general, if anybody's not understanding, because it really should be a tool to help you. It shouldn't be something that makes it harder or makes it more confusing. Okay, next example
Next page.
is example number 2. We're going to find 7 divided into 6,784. So they've estimated rounding the 6,700 up to 7,000 because 7 goes into 7 once, and then I would add the 3 zeros on the end. So my estimate looks like 1,000. Then I'm going to divide the hundreds, and in this case there's not enough hundreds to divide because 7 does not fit into 6. So I'm going to put my placeholder there. Then I'll divide 7 into 67. Anybody know how many times that fits? How many times will 7 fit into 67? Hamza, how many times? 9 times. And what does that equal? 63. Then when I subtract, I get 4. Bring down my 8. So remember, I'm still following the divide, multiply, subtract, bring down, repeat. Still the same steps as it was from the very beginning of this chapter. Now I'm dividing 7 into 48. How many times will 7 fit into 48? I see some people thinking. Angelina, what do you think?
6 times.
6 times. Almost 7, right? But not quite. So 6 times 7 is 42. Then when I subtract, I get 6. Bring down the 4. So 7 into 64. We know because we already did 67, right? So we already did that 9 times again. With a remainder of 1. So 6,784 divided by 7 is 969, remainder 1. Again, each of your numbers here should have a number above it. That helps you know that you didn't miss anything. And if we check for reasonableness, 969 is pretty close to 1,000, which was our estimate. So I want you to try the 2 guided practice questions with the people that you're sitting with in your group. And then I'm gonna give you the answers to these in a couple of minutes. So do those with your group. Make sure that you and your group members have the same answer.